Hey, how you doing? I'm Elton, and this is part 5 of Modernizing .NET Apps for Developers, a series showing you how to run existing .NET Framework apps in containers and use the Docker platform to modernize the application architecture. So far, I've made some big improvements to my application with very little effort. I moved the original monolithic app into Docker, which made it easy to break features out and add new features. Now I have a modern architecture and a modern delivery process, and I've integrated my ASP.NET Web Forms app with some great open source software. This is the final part of the series, where I'll break one more feature out of the original app and show you how you can use the Docker platform to bring a new technology stack into your application landscape. Let's see what's going to happen in this video. With my new architecture, it's easy to change or add back-end features, and now I'm going to show you an approach for breaking down the front end of the application too. I'm going to add a new container which serves the application homepage. All the other logic will stay as it is, but this is an important change. Apps often have UI components that business owners want to change frequently. They want to experiment with different designs and different UX flows, and that's often an iterative process. But for that to work well, they need IT to support them with fast releases. If the UI feature is part of a big traditional code base, then every release will need a full regression test, which could well take days or weeks. In my demo app, it's the application homepage that needs to change frequently, and I can support the business by moving that feature into its own container. Then I can release a new version without doing a full regression test of the whole app. I only need to test the new UI changes, and when I'm ready to do the release, it's just a case of replacing one container. This helps the business, and it also gives me freedom to use different technologies. I've written my replacement homepage as a static HTML application using the Vue JavaScript library. This is the Docker file for my new homepage. It's incredibly simple, as you can see. The escape line just means I want to use backticks for line breaks inside the Docker file. The default is to use backslashes, which conflicts with Windows file paths. Then, I'm starting from a Microsoft image which is based on Nano Server and has IIS already configured. My homepage is just an HTML site, so I don't need any of the extra features I get in the full Windows Server core image. IIS is set up with the default website at inetpub www.root, so all I have to do is copy over my index page to that location. The HTML is pretty simple. I'm using Vue, which has a very nice fluid grid system, and a card object, which is how I'm showing the links on the new homepage. The last link is to the original sign up ASPX page, so this application needs to run in the same web domain as the original application. There are a couple of options to do that. I'll show you an easy one now and talk about a more flexible one after the demo. The easy option is to leave the original Web Forms application as the public-facing website and have the Web Forms app consume content from other components. Here, in the default ASPX page, code behind, I'm loading a URL from app-config, which is the source of the homepage. If that URL is configured, I load the content with an HTTP GET request and return that content from this page. So this is like a facade which delegates responsibility for content to the external homepage component. In the app settings file, I'm using a container name as the URL for the homepage, so all I need to do is make sure the new homepage container name matches this, and then it's reachable from the web app. I'll do that by adding the new component to my app definition in Docker Compose. In the Docker Compose file, I've added a new service for the homepage, and this doesn't need any special configuration, just the image name and the application network to connect. I've specified the homepage service as a dependency for the web app, and I've bumped the application image version because the code has changed with the new default ASPX logic. In the build override, I've got the details for the homepage, and I can use Docker Compose to build the app. The build script I use on the CI server works just as well on my local machine. When I run this, all the images get built, but almost every layer will come from the cache. Only the new homepage component and the changed web forms app actually get built, so the build is pretty quick. I'll use the local script to start the app, and while that's running, I'll quickly show you the end-to-end test suite that I have. I'm using SpecFlow, which is a tool for defining tests with simple given, when, then syntax. My test opens the sign up page, enters all the details, presses the go button, and then verifies that the thank you page comes up rather than the error page, and that the data is saved. All these examples use different sets of data, and SpecFlow generates an NUnit test for each one. Each executes the same code for the steps. I'm using a headless browser so I can run this test suite in a container with no UI. I browse to the URL, then insert the test data into the web form. After clicking the button, I check the next page is the expected thank you page, and then connect to SQL Server and verify the data is there with a simple select statement. The CI test script builds those end-to-end tests into a Docker image and runs the container to execute the tests. This container is in the same Docker network as the rest of the app, so the test can reach the web and database containers by name. Once the test is complete, the script copies the NUnit result XML file out of the container and checks the value of the result field. I'll run this now, and while it's running, I'll browse to the web application. This is my new homepage with the view cards, so the front-end integration is all working correctly, and I can browse to the sign-up page and see the original form. Back in the console, the test run has finished. I can see it succeeded, so all those tests have passed. The end-to-end tests give me confidence that my new changes don't break any existing logic, so this is good to deploy, which I'll do with my full CI/CD pipeline just after I recap the new feature. I've broken a UI feature out of my original monolith and run it in a separate container. Now I can completely change the homepage and just release those changes to production. Nothing else in the app needs to change, and nothing else needs manual testing. This example uses a very simple approach. The original web app is still the only public web application, and the homepage is an internal component which gets used by the web app. That works well for this scenario, but if I want to break more pieces out of the original front end, I need to make more changes to the original app to delegate those new pieces of content. A better approach would be to run a reverse proxy as the public entry point to the app. You can run IIS in a container configured as a reverse proxy, and you set up routing rules to say where the proxy fetches content. Then the original web forms app doesn't need to change. When you want to deploy a new UI component, you just run a new container for the new content and update the routing rules in the proxy. The great thing about the Docker platform is that it doesn't mandate any particular design. If my simple approach works for you, that's fine, but if you want more flexibility, Docker supports you with that too. We're coming to the end of the series, so I'll finish up by releasing the new version to production using my CI/CD pipeline and showing you how it all looks. My compose file has a service in it for the new homepage, and the production override has the additional information for the homepage service. I've added a deployment PowerShell script to the CI folder, which uses Docker Compose to join the application and production compose files, and then uses Docker Stack Deploy to deploy the app. I'm using a different config object for the deployment, prod config, and the idea is that this will point to my production Docker cluster running in the cloud. I've added this as a step in my Jenkins job, and I'm using a different set of secrets and a URL from my production deployment. I'll kick this job off now, and it will go through all the steps. Building images and running containers on the CI server, running the tests, pushing the new images, and then deploying straight to production. And this is using basically the same Docker Compose file for all those steps, with additional Compose files for specific parts, and I'm using the same Docker tools that I used locally. And of course, when the production deployment completes, it's going to be running the same application binaries that have passed my CI tests and running on the same Docker platform. The CI/CD job has completed, and the last log entries show the services being updated in my production environment. I'll check the stack now on UCP. The new homepage service is there and it's running, so I'll browse to the Azure Load Balancer to check the changes. This is my shiny new UI, so that looks good, and I can click through and enter some details here. I'll complete the form just to make sure there are no errors and submit it to publish that event onto the message queue. The backend logic is the same with this release, so the data gets saved to SQL Server and to Elasticsearch. I'll browse to Kibana and I can see the new data I've just added, and I've also built a quick dashboard here. This shows the overall number of signups and the breakdown by country and job role, and it's the sort of thing a power user could build for themselves in a few minutes. Back in UCP, I now have containers running .NET Web Forms apps, .NET Console apps, Java, Node.js and plain HTML, and I build, ship and run them all in the same way. And that's the end of the series. I started with a monolithic ASP.NET 3.5 application, and over 5 videos I now have a distributed application running across many containers, which is easy to build, deploy, upgrade, scale and manage. I've modernized the application architecture and introduced some enterprise-grade open source software, which has made it really easy to add new features to my application. I've fixed a performance bottleneck, added self-service analytics, and made it really fast for business users to release UI updates, all without doing a full rewrite. The bulk of my code is still in the original ASP.NET Web Forms app, but I've extracted those high-value features into separate components running in their own Docker containers. Those separate units can have their own release cadence and run at their own scale. They can even use different technology stacks, but they all have the same build, ship and run workflow powered by Docker. If you want to get started modernizing your own apps with Docker, head to the Play with Docker training site, which is an online environment with Docker configured that has lots of great tutorials. And if you want us at Docker to help you modernize your application suite, head to docker.com/MTA to learn how we partner Docker architects with infrastructure providers like Microsoft and consultancies like Accenture to bring your apps into the modern world.